Namaste children. Today we are going to start with a new chapter, Units and Measurement. In that, first we should know what do you mean by a physical quantity. A measurable quantity is called a physical quantity. There are two types of a physical quantity, that is one fundamental quantity and derived quantity. The quantity which are independent of other physical quantities are known as a fundamental quantities like length, mass, time, which does not depend on any other physical quantity. They are independently, you can say, as measurable length, L, mass, that is with you are measuring sugar, like how much kg, like that, mass, time. So these are the fundamental physical quantities. Another one is a derived physical quantity, which are derived from the fundamental quantities. With a combination of one or two fundamental quantities, we will get one more special quantity, that is a derived physical quantity like velocity, acceleration and all. What is unit? That is, each physical quantities we require to measure it. So what is unit? So it is internationally accepted reference standard quantity comparing which a physical quantity is expressed is called a unit of that particular physical quantity. Units of fundamental physical quantities are called fundamental unit, and units of derived physical quantities are called derived units. System of unit is a complete set of units of both fundamental and derived physical quantities. So we are having fundamental physical quantities and derived physical quantities, which one you can measure. So all are having its own units. In the beginning, FPS is a first unit system which measures a mass in pound, length, foot, time, second. Later, after certain years, there is a CGS system, that is mass measuring unit gram, length, centimeter, time, second. Similarly, MKS unit system, mass, kilogram, length we are measuring in meter, time in second. So like that we are having a FES, CGS, MKS. As the year gone, we are having many other physical quantities like temperature, luminous intensity, electric current, amount of substance. So these units we are introduced in a science and we have to measure it. So one more new system came, that is a SI unit, system of internationally the units. It's an extension of MKS unit system. Mass already you know, the unit is kilogram, length meter, time second. Temperature we can measure with the unit Kelvin. Luminous intensity candela, electric current ampere, and amount of substance mole. With its own a small letter symbol. In few physical quantities having a symbol with even with a capital letter also. So we should follow particular rules when you are writing a symbol. Temperature Kelvin, as I said, it's a capital K. Like that we are having so many physical quantities and derived physical quantities. As a science developed, we have introduced with two more supplementary quantities like a plane angle and a solid angle. So supplementary quantities we can measure with a unit. So plane angle, radian, rad symbol. Solid angle, that is a steradian, it's a symbol with a SR. So further explanation for a plane angle is given, you can go through it, even for a solid angle. And even we should have a knowledge about multiples and submultiples of a unit. How you know about a kg? You know 10 to the power of 3, that is a kilo we say. Similarly, micro 10 to the power of minus 6. So like that the table has been shown over here, you can go through it. And we should know about the dimension and dimensional formula. So we know different physical quantities which includes both fundamental and derived. So the dimension, usually we measure these physical quantities with a mass, length, time we have said, no. Similarly, to know it in a detail, we can express the physical quantity in terms of a fundamental quantities called a dimensional formula. So we use for that a formula. So a formula in which physical quantity is expressed in terms of fundamental quantities. So like one particular example, if I take length, so dimensional formula I will write it as a capital L within a square bracket. Similarly, mass, capital M, time, capital T, temperature, capital K, current, we know the ampere unit, so the dimensional formula we will write capital A within a square bracket. Similarly, luminous intensity CD, small letter in square bracket, and also we can say molecules, that is a substance, amount of a substance, that is MOL, mole in a square bracket. So these are the few examples. Similarly, we have our derived physical quantities, which are made up of a fundamental physical quantity. Like one example, area, that is length into breadth. Both are in terms of a length we can write. So L, so we get L to the power of 2 inside the square bracket you have to write. So area is equal to L to the power of 2. Like that we are given with different examples that you can see. One more definition we should know here, dimensional equation. So what is it? A relation connecting a given physical quantity and its dimensional formula is called dimensional equation. So dimension of a physical quantity is the power to which the fundamental unit must be raised to obtain the unit of that particular physical quantity is what we call it as a dimension or a dimension formula. Suppose force. So you know it is mass into acceleration. So mass capital M, acceleration, dimensional formula L T minus T to the power of minus 2. So together we have to write M L T to the power minus 2 inside the square bracket. That is a dimensional formula for a force. So you should know to write the dimensions or a dimensional formula for all different physical quantities. So which have been shown in a table as here. Similarly, we should know about a few more concepts like dimensional variables. Quantities which possess a dimension and not have a constant value are called dimensional variables, like velocity, acceleration, momentum, force, volume. These are the physical quantities which is not having any constant value, which varies. So dimensional variables we call them. Similarly, we are having a non-dimensional variables. Quantities which have neither dimension nor have a constant value are called non-dimensional variables. Like a strain. Strain is nothing but a change in a length to the original length, that is a longitudinal strain. So meter upon meter only it will have. So there is no unit. So no dimension also. So like that we are having a non-dimensional variable. Dimensional constant means quantities which possess a dimensions and have a constant value are called dimensional constant. So physical quantities like a gravitational constant, Stephen's constant, Planck's constant, like that, which are having its own value, which is a constant value. So dimensional constant and does not possess any dimensions and have only a constant value. Similarly, non-dimensional constant means having a no dimensions, like a pure number or a pi 3.14 value, you know. Similarly, E, it is having its value, that is 2.718, and also even trigonometric functions are all come under a non-dimensional constants. So you should know all this in detail with all different examples like a quantity and dimensional formula. So velocity, you know, displacement divided by time. Displacement is a length, time t, but divided by time. So when you take it up, it will become t to the power minus 1. So LT minus 1 inside the square bracket. Similarly, all we have shown over here, you should know how to write in a proper format and you have to learn. One of the important point is here, principle of homogeneity of dimensions. What is it? Principle of homogeneity of dimension states that the dimensional formula of all the terms in an equation must be same, which is very, very important. Another very important concept in this chapter, often asked for a 5 marks and all, it is the applications of dimensional equations. Dimensional equations are used to check the correctness of equation, to derive the relation between a different physical quantities, and to convert one system of unit to another system, which is very, very important. This can be asked for a 5 marks separately. So few examples we can go through it. Before going through these examples, the limitation of dimensional equations also you must know can be asked in an exam. Like one of the main limitation, it is as we said, v is equal to u plus at, one of the equation. We can say it is dimensionally correct. But if I write v is equal to u plus 2at, it is false. Dimensionally it will be correct, but it is not proper. Yes, so it is not a dimensionally correct, but it is not truly correct. So you should know that it is, you should know the particular equation. So dimensionally you will say it is correct, but actually it is not. So it is one of the drawback. The constant of proportionality constant also we cannot be determined under a dimensional analysis, like a 2 pi, which is a constant actually, but this is we got experimentally and accepted all over the world, but it cannot be derived through a dimensional analysis. Similarly, we can't say about the trigonometric and logarithmic functions if it involves whether it is correct or wrong. So they cannot be used for deriving the equation involving a trigonometric and logarithmic function, the dimensional equations. This method cannot be used to derive the equation where addition or a subtraction also involved. So these are the few limitations about a dimensional equations, but applications we will go through it in detail. That is the first application, as we said, check the correctness of a given equation. Let us take one equation, v is equal to u plus at. Whether it is right or wrong, we have to know. Now this can be solved under the principle of homogeneity of dimensions. We will take each term in the equation from both LHS and RHS, and we will see that whether it is dimensionally correct or not. So we will take a v, the velocity or a final velocity. The dimensional formula L t to the power minus 1 is equal to u. Separately we have to write dimensional formula L, that is u is a initial velocity. So L length t minus 1, because you know initial velocity displacement divided by time. Similarly, we can have an acceleration and also time. Dimensional formula we have to write. And when we solve, you will come to know that each term in a given equation all are separately Lt minus 1, Lt minus 1 plus Lt to the power minus 1. So that means all the terms have the same dimensional formula, and hence the given equation is dimensionally correct. Like that we can prove. Similarly, we are having a different equations, and also you can prove with the help of that. Here I have shown with two more equations. You can go through it and you can check the correctness of given equation. Another application, as we said, we can derive the relation between the physical quantities given in a formula. So like t is equal to square root of L by G with a constant value 2 pi, it has been shown. But in another way also can be asked, but you cannot be depend also. Here in the question they have said mass of the pendulum m. So in the question they have given, so we will take it and whether we will check whether it is depend or not. If it depend, how much, in how many quantities, like that we have to see and give the equation, and we have to derive. So one of the equation according to the question, the time period of oscillation t depends upon a mass to the power of how many times we don't know, so to power of x. Length of the pendulum L we have taken to the power of y. Acceleration due to gravity, the symbol g we have taken, how many times we don't know, so we write to the power of z. Proportionality constant we have replaced with a k, capital K, or a small k also you can write, and which the value we don't know now. So only under dimensional formula we will see that whether it depend or not with a dimensional quantities. So capital T is a time period, means time. M0, L0, t to the power 1, time t, 1, is equal to mass, capital M, how many times, x power. Length L, capital Y, that is how many times it depends, to the power y we have written. We don't know now, so just we have to write x, y like that. Similarly G, that is acceleration due to gravity, nothing but equal to acceleration. So formula is L 1 time and t to the power of minus 2 we have to write, and whole to the power of z. And we have to write in a proper format. Mass you have to see how many times, only x. Length we can see, that is to the power of y and to the power of z. So y plus z. T minus 2 into z, so minus 2z. And later we have to compare the dimensions of LHS and RHS in an equation. So based upon that we get x equal to 0, that is m to the power of 0 it is. L to the power of y plus z, here it is 0, so y plus z equal to 0, another side. Similarly, here t to the power of 1 and here other side t to the power of minus 2z, so minus 2z is equal to 1. So from that z is equal to minus half we get. So substituting z is equal to minus half in a y plus z equal to 0 equation, we will get y also, that is value is equal to half, but x equal to 0. So it does not depend upon mass. So we came to know. So mass 0 times length, it depends half to the power half y it is, and g we got to the power of minus half. So minus half means we can write L by g and whole to the power of half. So half is nothing but square root. So we can replace with the square root. So as I said, proportionality constant k. So t is equal to k into square root of L by g. We derived the relation with the help of dimensional formula. And as we said, k dimensional constant which have proved in a laboratory, we will take it as a 2 pi. So t is equal to 2 pi into square root of L by g is the answer. So like that we can derive many relations with the help of a dimensional analysis, and that is for E is equal to half mv square we have showed, that is a kinetic energy. And similarly we can derive F is equal to mv square by r, which is where F is a centripetal force, mass m and velocity v, and r the radius of a circular path described by the body. So we can derive like that with the help of a dimensional analysis. So you can go through these examples. One more derivation is there. F is equal to 1 by 2L into square root of T by M, where T is the tension like a force. So you can see here how the dimensional formula written properly, and the equation has been compared with the LHS and RHS side, and then we got the x, y, z value and placing them in a proper format and getting the equation which they require. So we can do with the help of a dimensional formula. So using dimensional analysis we can derive the relation. One more application we said, that converting from one system to another system. So here force we have converted from one system to another system, like from Newton to dyne, like that we can derive. So you can see that is MKS unit of force is equal to how many times we don't know. So N into CGS unit of force. Therefore N is equal to MKS unit of force divided by CGS unit of force. What is force? You know, mass into acceleration. Mass is m. Acceleration is L t to the power minus 2. Here we have taken m1, L1, t1 for a MKS system or a SI system, and m2, L2, t2 the fundamental units of a mass, length and time under a CGS system. So we can see here on solving kg meter per second square, here in the down CGS gram centimeter per second square. So you know gram you can convert into kg, 10 to the power of minus 3 kg. Centimeter you are convert into a meter, 10 to the power of minus 2 meter. And 1 second square is 1 second square only in meter, MKS system also. So you have converted in a kg to, that is a kg meter second per second square. It is in a MKS system or a SI system. Similarly CGS system which you have converted into a SI or a MKS system, gram centimeter per second square can be written 10 to the power of minus 3 kg, 10 to the power of minus 2 meter, and second to the power of minus 2. We get 10 to the power of 5. So MKS unit of force is a 1 Newton is equal to 10 to the power of 5 CGS unit, that is dyne. So we have derived it. Like that we can have so many problems. One more we have given with a work that is a unit in SI system joule, and CGS unit work is a erg. So we will derive here, that is 1 joule is equal to 10 to the power of 7 erg. So you should know to derive it and learn it. Yes. Thank you. Good luck.